Hi there, students. This is Dr. John, your physics and math professor. I'm going to today help you to understand the different names we give to different types or sets of numbers. First of all, there's natural numbers, whole numbers, integer numbers or just integers, rational numbers, irrational numbers, and real numbers. And I'm going to use a number line to define some of them in different colors so that you can set them apart. First of all, natural numbers. Natural numbers are easy to remember because they're the numbers that a child would naturally learn. Well, they would naturally learn numbers like 1, 2, 3, 4, 5, counting upward. They would not learn zero. Zero is sort of an odd concept. They would not learn negative numbers. Just these numbers. These are the natural ones. That's an easy way to remember that, the numbers that a child would learn. And then if you want to add the number 0 to natural numbers, think of 0 as a hole. It's nothing. It's a hole in the ground. There's nothing in it. So that's a different kind of a spelling for the word whole than this word whole, but that gives you the whole numbers. So it's all the natural numbers, 1, 2, 3, all the way up to infinity, plus 0 gives you the whole numbers. That helps you to remember natural numbers and whole numbers. Often these are abbreviated for N for natural numbers, and sometimes they'll say W for whole numbers. So they'll say your set of possible answers is all the natural numbers or all the whole numbers, and this is what they're looking at here. And then when we get to this third type of numbers, which is integers, what we do is we take all these natural numbers and give them their negatives as well. So it's 1, 2, 3, 4, 5 to infinity, adding 0 for the whole numbers, and then this time we also add all the negative numbers, -1, -2, all the way to negative infinity. So those are the integers. They differ by each other by 1 unit, by an integer. Sometimes we'll use the word that way. So those are these 3 different types of numbers here. Now we're going to go to this side over here, and I'll use different colors for that. Let's start off with these rational numbers. Now, what we use the word in English often, rational, is my friend is being rational. That is, he's being logical, or I can understand what's going to happen next. But in this case, this word doesn't come from that. It comes from the word ratio. The word ratio, it means one thing over another. It would be one number over another. We would think of that as one natural number over another. So, for example, 2 over 5 is a rational number. It's a ratio of 2 numbers. 1 over 2 is 1/2. It's a rational number. Any natural number over another number. We don't really need 0 there because 0 over 5 is sort of boring. That's just 0. I guess you could use that, but you can't have anything over 0. That's not permitted, so you can't do that. So I'm going to erase a couple of these things here. And something that you need to realize is any number like this, any rational number, can be put straight on this number line right here, just like this. So if I wanted to put 1/2, it would go right there. That's 1/2. If I wanted to put 4 1/4, 4.25, or 4 1/4, or if I want to make that a whole fraction, I multiply this, add this, so that'd be 17/4. That would be right there. Numbers that can be represented by a decimal or a fraction like this can go directly on the number line. Those are called rational numbers. So sometimes you'll have a number like this, 4.230. That's a rational number even though it has a number of different decimals on it. Or something like this, 1/3 is represented as 0.333, and that repeats. Sometimes we'll write it this way, 0.3 with a bar on top, which means repeats. Any decimal that repeats is a rational number. And the way that you can remember that is you know exactly what the next decimal is. You don't have to guess. Just like your friend who's rational, you know how he's going to behave next. You know what his behavior is going to be based upon the situation. In the same way, you know exactly what the next decimal is. If that's the case, it's a rational number. It's a rational person. It's a rational number. That's a different use of the word rational. I'm just giving you an illustration to help you remember how to remember the word rational. And in a similar way, the word irrational, of course, means you cannot make it as a fraction. So a number like pi, which is 3.1415926, and that continues on forever. You have a number of decimals like this, and the thing about pi is you do not know what the next decimal is going to be. If you just knew this far and you were trying to guess what the next decimal is without calculating it or memorizing it, you wouldn't know. In other words, irrational numbers, if you put them in decimal form, you can't guess what their next decimal is. In the same way, in an irrational person, you don't know what their behavior is going to be in a certain situation. They're being irrational. In this case, it's a different meaning for the word irrational, but if that helps you to remember, you don't know what the next decimal is, so they're irrational. Now, this also you cannot make as a fraction. You can make approximations like that. 22 over 7, let's say you make an approximation. This would be a rational number, but this is an irrational number. And the thing about this is if you're trying to put this onto the number line, let me just erase a couple of these things here. you would say, well, 3.1 would be right there. 3.14 is very close to that. 3.1415 is very close to that. 3.1415926 is very close to that. But every time you add a couple of more decimals, you're going to be moving exactly where it is on the number line. It's somewhere over here. But you don't know exactly where it is because you don't know exactly what the next decimal is. So you can put irrational numbers on the number line, but you don't know exactly where they are, which makes them in another way sort of irrational. The most well-known irrational number is pi, but there's others as well, like e, which you're going to use a lot in mathematics and biology and finance and all that sort of stuff. Something like the root of 2, the root of 5, various different sign functions, all sorts of different things that do not represent themselves as an exact fraction of two natural or two whole numbers, with 0 being on the top, of course, are irrational. This is some sort of decimal that doesn't repeat. This is some sort of decimal that doesn't repeat. You can all put them approximately on the number line, but you don't know exactly where they are, hence a little bit more irrational. But the real definition of irrational is you cannot represent these as two fractions. So now we're going to look at this last type of number, the real numbers. A real number is any rational number or any irrational number. The combination of both of these forms real numbers. So anything that could be anywhere on this number line, going to infinity that way, going to infinity that way, if you know the exact spot or the approximate spot, those would all be real numbers. And of course, that would include all of these as well. So the way that you would write these different things is this you might write as an N, this is an I, this is a W, and this you would often represent as an R. Sometimes they'll make a double bar there. And you might see this in your mathematics. X that's like an E. It's actually a Greek letter, capital Greek letter E. X is an element of, that's what that stands for, R, or the real numbers. That means the X that you're going to use, the unknown value you're going to use, is one of the real numbers. In other words, it could be any number. A rational number, an irrational number, or a rational number like these that we plotted here, or anything in between. X is an element of the real numbers. Sometimes it's done with the R, sometimes with like a double bar in the front, so you could have it either way. Now you might think if there's real numbers, if all these types, are there something like non-real numbers or imaginary numbers? Imaginary numbers. Yes, there are. They're often represented by an I, and the way that they're defined is this way. The square root of -1 is equal to I. It's an imaginary number. Remember, you cannot take the square root of a negative number. It just doesn't, it's not a real thing. Not a real thing. It's an imaginary thing. And we use this in various mathematics things, probably higher grade level, a higher challenging grade 12 level or university. So don't worry about this right now, but just realize that there is such a thing. You don't need it though in most cases. So I hope that helps. If it does, like and subscribe, and I'll see you in the next video. Bye-bye.